previous part, we have created the demo Fargate new Fargate profile, and in this part, we'll be configuring the Kubernetes cluster so that it deploys our application. So first of all, you will have to create a deployment.yaml file. I'll explain what is happening in this file later in the video. But first, I need to give you a brief about what is deployment, what is service, and what is an ingress. So first of all, a deployment is used to manage and scale a set of pods. So what this means is that pods will be running our application based on the images we have created. So we can mention how many replicas of the application we want on the cluster. So for example, if I specified a replica sets to be 3, then 3 pods will be running our application. And we can also use deployment for updating our application or rolling it back to the previous version. So deployment ensures desired number of pods and automatically handles the scaling and rolling updates. Now what this basically means is that whenever I specify replica sets to be 3, then there will be 3 pods which will be running my application. Now these 3 pods will have some IP, and I can go to that IP and use my application. But what if one of the pods go down, or what if one of them is facing some error? So in that case, I cannot go and tell my user that you need to now access this IP to use the application. That is a very bad practice. So for that, we have created something known as service. Now what service will do is that service will act as an endpoint from where the user can use our application, and then service can contact all the pods which we have created using deployment. For example, the IP of one of the containers has changed. So the service can use its property of service discovery, and it can point to that pod using the namespace which we will be creating. So the user will not be concerned with accessing the right IP, but it will be the task of service. So what service does is that it exposes a set of pods to the network, providing networking and load balancing. So it ensures stable network endpoints for dynamic pods that may change IP addresses. So that was the point I explained earlier. And there are 3 type of services, and all of them are very important. First of all, cluster IP. So our application will be initially or by default by accessible from within the cluster only. So that type of service is cluster IP. If I'm testing, if I want to check if the service is running properly or not, I can use cluster IP mode. And second is node port. If my organization has access to my PC or the network, then I can use node port so that anybody from my organization can access the cluster. And third is load balancer type. This load balancer type will be used to give public access of our application or of our cluster to the user or to the outer world. So now we need to understand why we are using Ingress. So each of these services are also backed by a load balancer. For example, if a user comes, so it will be first greeted by, it will send the request to load balancer, and then load balancer will give the request to one of the services. So this was causing a lot of problem of cost, because they had to create a lot of load balancer for services because there were multiple services. So it increased the cost a lot. So for this, Kubernetes acknowledged this and create something known as Ingress. So what Ingress does is that Ingress is a Kubernetes resource that manages external HTTP and HTTPS traffic and routes it to service based on rules. So now we are creating a load balancer which will redirect the traffic to the required service. So for example, the purpose of this is it acts as a reverse proxy for routing traffic, provides host-based and path-based routing. For example, if I want to access /API or /dashboard, so Ingress can help me accordingly from the rules which we will be configuring in the deployment file. And it also has some important features, other features such as SSL and TLS termination. You can read about them. It's a kind of advanced topics. And for this project, we'll not be requiring SSL extra techniques. So it Ingress is basically used to consolidate multiple services under a single domain, and it allows traffic rules like path-based routing. So this Ingress is like a resource, but there are multiple Ingress controllers. To access the Ingress, we need to have an Ingress controller, and this Ingress controller logic can be defined by you as well, or you can use existing Ingress controller logic provided by Nginx or some other load balancer company. So this Ingress resource or Ingress controller will help us to maintain sticky sessions, then role-based access, and a lot of things. So I'll now move on to the deployment file. So firstly, we'll be creating the namespace for our application app whiteboard, and then we'll be you can see the kind namespace here, and then we'll be using deployment. So deployment, we will be giving a name to this deployment, which is deployment app whiteboard, and I'm specifying 3 replicas here. And then I'm using a selector that it should match this name. So our deployment will be identified using React whiteboard. This is an important part. You need to mention the selector efficiently so that other services or other resources of Kubernetes can access this deployment. And third is label. We need to give this a label as well. I have given the same label, React whiteboard, and we need to specify the container name. So we had earlier created the image, and we have pushed it to Docker up as well. So this will access my Docker up repository and get the latest React drawing image. And I've also mentioned the container port, which is 80. Now now we are using service. So I've given a name to service, which is app whiteboard, and I've given the name to the service such as service app whiteboard, and I've specified the target port, which is 80, and this service will be running on port 80 as well. And I've used a selector as mentioned earlier. It will be used to map with the deployment file. And the fourth is ingress logic. So in ingress, I have defined, it is basically a configuration for the load balancer. So I have defined it as internet facing IP, and it will be listening to ports 80. You can modify here as well based on your application. And for ingress controller, we'll be using the Amazon's application load balancer. So I have given it a name here, ingress class name as ALB, and I've defined the rules such as it will be accessing the root path, and it will direct to the service in the backend, which is service app whiteboard, and I've given it a port as well, port 80. So now we need to apply this deployment file. For this, we'll have to perform a number of steps. Firstly, we will most of the people who use Kubernetes use kubectl for interacting with the cluster. So we have to point kubectl to our cluster, which we created on created using EKS. So for this, you need to write this command: AWS EKS kube update kubeconfig name drawing app and region AP South 1. So what this will do is that we can access our cluster using kubectl, which is a standard way of accessing clusters. So now I'm on the same repository such as in my where the deployment file is present. So I'll use kubectl apply -f deployment.yaml. So if I see here now, see, new namespace is created, new deployment is created, new service is created, and new ingress is created. So I can write this command kubectl get pods -m app whiteboard. See. So now you can see we are, as I mentioned in the deployment file, we'll be using three replica sets. So three pods are ready. It is in the pending state right now. To know the service, we can use kubectl get service and the name of the namespace. See, service app whiteboard, it is also created and it is in the cluster IP mode. And next is the ingress, kubectl get ingress. See, ingress, it is not yet started, and as you see here, the address is not mentioned here. So to get the address, we will have to configure the application load balancer, which is the ingress controller. Ingress is useless without the ingress controller, so we'll need to configure ingress controller first, which we can use to access our application. So I'll show you in the console as well how it will be looking. If I go to the resources, see, 3 new pods are created as I showed you through the terminal as well. New deployment is also present. If I go to the cluster and if I go to the service and networking, you can see the ingress app whiteboard. It is also created, but it will not have any load balancer or application. If I show here, see, it is just it does not have any label or any events which it is not accessed yet, and there's no link here as well from where we can access the application. So this was for this part, and in the next part we'll be configuring OIDC, and after that I'll show you how you can create the ingress controller application load balancer and how we can access the application.